This theory is used to predict the rates of chemical reactions, that particularly on gases. The collision theory is based on the assumption for the reaction to occur, and is necessary for the molecules to collide with one another. There are three requirements need to fulfill in order for the reaction to occur, and forming a products. The reactant molecules will experience effective collision. The three requirements are reactants must collide, sufficient energy, and correct orientation. As you guys can see, the reactants here have sufficient energy and correct orientation for reaction to take place. There are three assumptions of collisions theory. First is gas molecules are impenetrable hard spheres. Second, no interaction occurs between them except at the moment of collision. Third, their collisions are elastic. The first assumption of collision theory is that the particles must collide with one another in order to form a reaction. When they collide, they bounce off each other. The collision of particles itself is not all that's needed for a reaction to occur. The particles also need to have enough energy and enough speed to break and form new bonds. The activation energy is the minimum energy requires for a reaction to occur. Next, we look at how the temperature will affect the rate of collisions. This is the demonstration of molecules collide each other in high temperature. Generally speaking, most reactions will occur faster when the temperature is increased because temperature is the average kinetic energy of the particles. With more kinetic energy, they will be more likely to have enough activation energy for the reaction to occur. Additionally, there's one more factor that we need to consider. Orientation. Even if the particles collide with sufficient speed, if they aren't at the correct angle, a reaction won't happen. However, in this collision of the same molecules will occur when the sodium ion touches with chloride ion during the collisions making water and sodium chloride. The orientation was correct, so the reaction could occur. From the collision cross-section, we can know the number of collisions made by one molecule per unit time. All molecules with centers inside the tube will hit C, while those outside the tube will miss it. Each molecule being hit is considered as one collision.
Chemical kinetics is the branch of chemistry that studies the rates at which chemical reactions occur and the factors that influence these rates.
A reaction increases with an increase in temperature. Generally, the rate of a reaction doubles for every 10 Kelvin rise in temperature.
As temperature increases, the kinetic energy of the molecules also increases. This leads to a higher frequency of collisions and, importantly, an increase in the number of collisions that have enough energy to overcome the activation energy barrier, resulting in a higher reaction rate.
Molecular collisions in gases are central to a broad spectrum of physical and chemical phenomena. They play a critical role in determining the behavior and properties of gases, from fundamental aspects like pressure and temperature to more complex interactions involved in chemical reactions and transport processes. These simplifications allow scientists to derive equations that correlate well with experimental data, offering insights into key factors influencing reaction rates, such as temperature, concentration, and activation energy. Despite their limitations, these assumptions help generalize principles across a wide range of chemical reactions, facilitating advancements in fields like catalysis, atmospheric science, and engineering. Collision theory occurs at certain chemical reactions and rates. The fundamental principle is that in order to react, molecules must undergo effective collisions. In order to undergo an effective collision, the molecule's collision energy must be greater than or equal to activation energy during the reaction. Reactants with low concentration result in few collisions, and those with high concentrations produce more collisions. There are three requirements to occur molecular collisions, which are reactant must collide, sufficient energy, and in proper orientation. The assumption of collision theory are essential for simplifying the complex nature of molecular interactions, allowing for practical and predictive models of reaction rates. Chemical kinetics not only provides a quantitative understanding of how fast reactions occur, but also deepens our understanding of the molecular level events that underpin chemical processes. This knowledge is crucial for advancing both theoretical and applied chemistry. The rate of a chemical reaction depends on several factors, including the concentration of reactants, temperature, surface area of solid reactants, and the presence of catalysts or inhibitors. The rate law expresses the rate of a reaction as a function of the concentration of reactants. The reaction order is determined experimentally and indicates how the rate is affected by the concentration of each reactant.